Good evening. I'm El Nally, Membership Chair of the Twin Cities IEEE, and welcome to our webinar, Celebrating Engineers Week with 3 parts. Engineers Week, Celebrating Engineering, is presented by Ahmed Nauman. Why I Became an Engineer, Interviews and Tips, is presented by Rob Sleeser. And Opportunities in the Twin Cities IEEE is presented by me.
Happy Engineers Week, everyone, and welcome to this webinar celebrating engineering. My name is Ahmed Nauman, and I'd like to share with you why I think engineering is awesome. I've worked in both industry and academia, so I have a little bit of perspective on both the practice of engineering and education in engineering. So let's go through a few slides, and I'll share what I found with you. This is an outline of my talk. Well, we are in Engineers Week already, so I guess that slide is done. I would like to talk a little bit about education and then engineering and society, and then celebrating engineering, which is what this webinar is about. So here's a slide illustrating the kind of people who are interested in engineering. And this is not your stereotypical representation, right? A few years ago, some organization ran a campaign with people of different types, and the logo, I look like an engineer. And I always felt that it should have been, I am an engineer, and I look different, something like that. So anyway, there's a wide variety of people who are interested in solving problems of various kinds and in building things. And it doesn't matter what they look like as long as they're interested in problem solving, in creating, in building things that are solutions to problems that are being experienced by other people. So that's why we care about engineering, right? The world is built by engineers. And that is why both celebrating engineering and understanding it is important. I'd first like to talk about some current trends in education, because one of the distinctions between tinkering and engineering is that engineering is built on a set of theories which are then applied to the world. So preparing those foundations is very important, and that's the work of education. I should also point out that I make a distinction between engineering and technology, and maybe I should have allocated a couple of slides to that, but this is a short talk, so we will move on. So first, I'd like to talk a little bit about some trends in education in general. So learning resources are available from a variety of sources, and they're free. I mean, you can go on YouTube and find practically anything that you want in terms of engineering education. That's a pretty broad claim, but it's true. There's a wide variety of lectures and demonstrations that have been put on YouTube by academics, by practicing engineers, by hobbyists and others that'll teach you a lot. So that's one example. There are the massively open online courses that are available for free from several different providers. And then on the net in general, there's a lot of self-paced courses as well as other education that is available. Now, a college degree is still important, but the credit for that degree doesn't have to be gained from a single institution. And that's where packaging of credit from different sources is what I called it over here. But what it means is you can go to a community college, you can go to a 4-year college, maybe you can take an online course that is a credit-bearing course. Or you can take an exam like a CLEP exam and then get credit for a certain course or material. That can all be packaged together and count towards a degree program. In addition to that, there are certificates that can be gained from a variety of sources. The academic certificates, as well as there are vendor supplied certificates. By vendors here, I mean outfits like Cisco and Microsoft and Google and so forth, who make certificates available if you complete courses on their products. So those are product-specific courses, and that's why they're vendor certificates. And of course, there are many technology companies that want to supply tools, software-based tools that will customize learning for individual students. So the challenges that those students encounter or the pace at which they learn can be adjusted to their personal style and individuality. But this is also a good time to just talk a little bit about the distinction between education and training. So training is becoming familiar with specific tools and mechanisms and procedures, and maybe learning a little bit about a particular area or a type of technology or a particular tool. But that is not necessarily education. Education you can think of more in this fashion. It is a systematic introduction to multiple bodies of knowledge, not just technical stuff, but humanities, art, and other areas, because all of those go towards a holistic education, which in the end you'll see makes for a better engineer. So in addition to being a systematic introduction, and the word systematic here is important, to different areas of knowledge, education also provides an opportunity to integrate and synthesize the learning from these different areas of knowledge. And one very important aspect is then to have one's knowledge assessed as to how much one really learned. What is the degree of competency that one has in a certain discipline? This is what vendor certificates try to give you, okay? But those are training certificates, really, is what I'm trying to get across. When you get a college education, you're getting a degree in the foundations of different disciplines and the ability to synthesize that material together, and then, again, having your understanding and knowledge of that area examined by people who are qualified to do so. Most importantly, if you're getting a holistic education, it is an opportunity to define yourself, to find out who you are and what you want and how you view the world, and to be able to shape all of those things. And that's what the distinction, I think, to me at any rate, is one of the key distinctions between education and training. You can be trained in a variety of things and you need to know, and you can do those things. But that doesn't really lead to self-knowledge and self-realization. Okay, but education, if it's done properly, does allow you to achieve your potential and to realize the best self that you can be. Now, I'm going to mention this particular meme, if you will. It's been around for a long time. I mean, I came across it first, more than 20 years ago, in a seminar that I took, and this idea of T-shaped engineer, and people have ascribed it to IBM and Mitsubishi, and I don't know what the origin is, but the idea behind it is the following: that, and by the way, I should also add that this is being picked up by other disciplines, not just engineering. But the idea is that engineering is more than technical skills. People who are engineers have deep specialized knowledge in a certain area, but they're also capable of, and actually have, broad general and professional skills. So they're able to work with a variety of people, they're able to communicate effectively, and in general use this larger group of people to solve problems for that set of people, right? So it's not just, I know how to solve this equation. It's like, okay, I understand the challenge that you're facing, and I'll help you find a solution to that challenge for individuals, for groups of people, and for society at large. Okay, so what kind of engineers should we produce? So if you're graduating students who we say are going to be engineers and practice engineering, then these are the things that they should be able to do, which is, one, think critically. And critically here means being able to weigh the information that they have access to and understand if that information together makes sense or not. What is the piece that doesn't make sense, doesn't fit anything else, is not testable, etc., etc. So to be able to distinguish, I was going to say truth from falsehood, but maybe that's a little grandiose. Being able to distinguish correct information from incorrect information, that's part of being able to think critically. And being able to think systemically. This gets overlooked a lot, but it is very, very important. Actions have consequences. When engineers build things or do things, that has results which have consequences that stream out into the future and across geographies. So being able to understand what the consequences of your actions are is very important. And sometimes the problem is not a local problem, but it is the problem itself is a consequence of the way the different components of a system are acting together. So the ability to think systemically, both in terms of understanding problems and then in finding solutions that are sustainable, that's very important. Then in addition to that, being professionally skilled means being able to communicate, to work with a variety of people, to be able to understand and empathize with them. All of these things are important in being able to deliver a solution that is actually used by one or a large group of people, and that often gets overlooked. And you will note that technical competence is the last on this list. That doesn't mean that it's not important, but it does mean that if somebody's only technically competent, that means they can solve certain problems or they know certain technologies, but they don't know any of this stuff up here, the ability to think critically or think systemically and to be skilled in working with others. Their technical knowledge is not going to be usefully applied, right? So it's important to have all four of these characteristics in order to be both well-educated in engineering and to be a good practicing engineer. Okay, so far we have talked about students in education, but there are partners, and the other side of the equation, so to speak, is industry. What can industry do to work with educational institutions? That is an important thing for people in industry to focus on, because the educational institutions prepare their workforce that people in industry hire, right? So having an understanding of each other's needs and capabilities is pretty important. Sometimes hiring managers are looking to fulfill short-term needs. They want somebody who can do a certain thing now, right? And that's who they want to hire. And that's where they will often hire people who have certificates, particularly vendor-supplied certificates, right? But if they're good hiring managers and they're looking at the growth of their company as well as they care about the individuals that they're hiring and the growth of the career of those individuals, right? Then they will look at how good is the ability to learn. Do those individuals know or have they learned how to learn? Because technology will change. The kind of products that the company produces will change. The environment in which it operates will change. And the people, the engineers in particular who are working on that, need to be able to keep up with all of that and to educate themselves as they go along. So that learning how to learn becomes very important. Okay, so how can companies work with educational institutions? And there are many different ways of approaching this, but it's important that there be an alignment between the capability of an educational institution and the needs of a particular industry organization or company or segment, right? You wouldn't want to go to somebody who's graduating from an art school to find somebody who can build motors. Now, you may want a design person from the art school. I'm not saying that's not doable. But in such cases, maybe the company that's going to hire those individuals should go and have a conversation with the people who are running the art school and say, hey, we'd like people who can do design, mechanical design and drafting and things of that, and rendering, et cetera, and can you help us? So that kind of thing is always possible. You don't always have to think of equations and tools of that nature when you think about working with an educational institution. The other sorts of things that you can do is, well, first of all, just pick up the phone and call the department chairs and university presidents or college presidents and deans and the individual faculty and begin talking with them. Hire graduates from an institution on a regular basis. And this is important to establish long-term relationships. You can also serve on advisory committees. Most institutions have committees that advise on the curriculum and the degree programs, and you can serve on those. All right. And this piece is here, the one that the cursor is on, is pretty important. When you talk with people in educational institutions, it's really important that you tell them what you need the people that you are going to hire, the graduates that you're going to hire, what you need those graduates to do. You should not tell the educational institution, teach this, that, or the other. That is their job. It's their responsibility to figure out what to teach in order so that the engineers that you hire can do what it is that you want to do. Think of this as the distinction between a market requirements document and a product specification, right? When you're preparing a product, you want to understand what the market requirements are. You don't start writing the specification. The educational institutions will write the specifications that are a response to your market requirements. And this part is, well, I mean, this is more of the same, visit institutions and so forth, but this part is really, really, really important. Offer regular paid internships and co-op opportunities to students. Students have to, many of the students these days support themselves as they're putting themselves through college. Engineering is not cheap, okay? And being able to work in a company for a certain length of time, either as a co-op, 1 term studying, 1 term working in the company, or as an internship over the summer, or as a part-time job is really important. It gives them practical experience. It benefits you because oftentimes they're up on current technology, and also you can observe their work behavior and work patterns and capabilities. So when you go to hire them, you have a very good idea of just what they can do. But don't expect them to work for free. There's a tendency in many places to say, well, all right, we'll give you an internship or a co-op opportunity, but it's unpaid. Well, that doesn't really work well. Okay, so try and avoid that as much as you can. All right, you're in it to build a long-term partnership with educational institutions if you happen to be in industry, and vice versa. If you're at an educational institution, again, you cultivate a long-term relationship with the industry in your area. And these days, maybe out of your area because we are now doing so much stuff online. Okay, let's move on. Engineering and society. Well, here we're going to, I want to emphasize the same things again, the importance of critical and systemic thinking, okay? Because these days, and in the past too, everything is connected, right? So providing a point solution is generally not very helpful, okay? Think about some of the problems from your daily life that we encounter. I mean, for instance, packaged food is a good example. We buy lots of things in food and groceries and other items in packaged forms, but the disposal of that packaging, or it's going into the landfills. I mean, it's just massive amounts of plastic and related materials are going into the landfill. So it's an incomplete solution. Yeah, it's a good solution. The packaged food is stable, oftentimes shelf stable, so it doesn't even have to be frozen. In other cases, it lasts a long time. It's hygienic, it's and nutritious, and all of those things. That's a great service, right? But the end of the packaging needs to be taken into account as well. So this is the whole life cycle concept in terms of design and manufacture. And this is where it's important for engineers to be aware of this. And if you are an engineer, then this just illustrates that you have a responsibility. And it's not just finding the technical solution, but it's also about what is the impact on society of the solution that you found? And this is where ethics becomes important, because the deployment of different products, building different kinds of technologies, and particularly if they get adopted or adopted on a widespread basis, has consequences for the society and for the environment, or for the world at large. I mean, think about many of the technologies, if you happen to be in the IT area, the notion of surveillance. And surveillance happens whether it's not always spies looking out for to steal national secrets. Surveillance is also when your phone keeps sending data about the pages that you're browsing, and then suggests ads, or the game that you're playing, and pop things that you can buy. All of that is that is surveillance. That's how those companies knew about it. Is that the right thing to do? Is that the wrong thing to do? I mean, there are all kinds of ethical issues associated with this thing. So look at the project from both a technical and an ethical perspective. In other words, again, systemically, what is going to be the impact on society? All right. Okay, here's the thing. If you are an engineer and if you run into an ethically dubious situation and you blow the whistle, so to speak, Okay, there are consequences for that. And if you, or if your employment is threatened because you've done that, who is going to look out for you? This is, this is still, I think there's a lot of work that still needs to be done in this area to provide support and help for engineers when they challenge behavior that is unethical and has a destructive aspect on society. Okay. So back we are engineering, you know, because of all of those reasons, I feel pretty passionate about engineering, and I hope you too. Okay, and this is just a repeat of what I said earlier, is the development of the world in general has been a consequence of, maybe I should have used engineering instead of technology, but basically the tools and the products that engineering has made, which constitute the technology, that has enabled us to improve our quality of life over hundreds of years now, right? But given where we are today and the challenges that we face today, we need a holistic concept of engineering. You know, we need that full life cycle solution to the kind of challenges that we face. And so I hope this that you will think about the work that you do in those terms, because this is, I really like this quote from Theodore von Karman, or von Karman. He was an aerospace engineer, and he's reputed to have said this. I tried to track down the origin of this quote and asked librarians to help me, and it's not that easy to find it. There's one reference, and it doesn't have the quote exactly as this, but you can, as you read for yourself, von Karman says, scientists discover the world that exists, and here's the key part: engineers create the world that never was. Because engineers build the solutions. Everything around you today is a consequence of engineering in one form or the other. So I hope that if you are an engineer, you pat yourself on the back. And if you're a student looking to become an engineer, you're excited about what you're going to learn and what you're going to do. Because engineering is only as good as the engineers who practice it. This is, you know, remember I said at the start of this talk, is that's an opportunity to discover yourself and to make yourself. Well, you know, the better you make yourself, the better an engineer you are going to be, and the better you will make the world. So, because the world has been and will continue to be made by engineers. Okay, and I think that's awesome. So, thanks for listening to me.
Thank you so much for agreeing to chat with me today, Brendan. I want to start by saying it's been a lot of fun having you in our engineering program and really getting to know you. And I know you're approaching completing your engineering degree. When do you graduate?
May 2023.
May 2023, so that's coming quickly. What was your path to engineering?
I always kind of suspected I wanted to do engineering. My dad was an engineer, so I got exposed to some of that with the stories he tell about work.
Okay.
I enjoyed fixing things, taking things apart. Much better putting them back together now.
Where did you start your path? So you went through high school, and in high school, how did you prepare to move into college level engineering spaces?
Well, I took I took math through, what was it, Intro to Calculus, my senior year in high school. And then, I took a programming class, but
And so then you went into the college space. Can you tell me about the transition from high school to college?
yeah, so I went and looked at different colleges and Minnesota, the Dakotas, Wisconsin, Iowa. And initially I went to University of St. Thomas in St. Paul. So I was there for 2.5 semesters or so, and then I withdrew. 'Cause I decided that wasn't for me. I wasn't really connecting with people. And I took some time off and got a job at a hardware store for a bit to rethink what I wanted to do. So then I went to Inver Hills Community College, and somewhere in that process I heard about Twin Cities Engineering, and eventually found out a bit more about it. Ended up taking some classes at Normandale. Just walked by the labs one day and stopped in and thought like, hey, this seems like a place I'd like.
Would you be willing to share the most challenging times of your path to becoming an engineer?
I have to say, withdrawing from school, having to rethink what I was going to do, that was challenging, and the thought was there that maybe I couldn't do this, and that was devastating. That was a big challenge also.
So you sort of talked about that soul searching. I imagine that going through that process has strengthened you in some very potent ways.
Yeah.
How do you approach the world differently because of that journey? And
To some degree, it helped me realize that, yes, this is what I want to do, this is what I'm good at. And yeah, so you have to try things. It's more that I remind myself that I am going to fail, and that you have to work through that, and that when you fail, you learn a lot, and if you do it well, you can learn a lot relatively quickly.
what do you hope the future holds for you?
I want to find a stable job in engineering, want to do something that's interesting, and
What-
challenging.
What kinds of things would be interesting and challenging to you as you move into the next phase of your career?
Degree, I seem to find things I like in all sorts of things I do. Yeah.
I think that's a fair statement.
Yeah.
I see that oftentimes when you're left to sit with a problem, again, back to that natural curiosity,
Yep.
you scratch and gnaw and dig and circle around it.
Yeah.
But given any content, if somebody needs deep understanding
Yep.
and really sticky, really wicked problems, and one of the things I see about you is that you apply knowledge across domains very effectively. I don't know where you should end up yet. However, I know that once you end up where you belong, you will be incredibly powerful. One last question, and that is for those people that are perhaps interested in learning a little bit more about you, whether it's because part of your journey resonated with them and they're interested in pursuing engineering education and would like to reach out, or because they see that you could have a space in their organization, and they might have that right career path for you, what's the best way for them to reach out to you?
By email.
Okay.
Yeah. Let's say this.
Which,
Probably brendan.dykes@gmail.com.
okay. So brendan.dykes@gmail.com.
Yep.
I've put it here
Mhm.
so that you get the spelling and everything of it as appropriate.
Yep.
Thank you so much for your time today, Brendan. I really appreciate it. And I better let you get back to the work because I hear you've got professors that have ridiculously high expectations.
Yeah.
Thanks much. Hey, Giordano.
Good morning, Rob.
Thanks for coming in to chat with me today about your journey to being an engineer. I know you're still in the middle of that journey, but I'd like to ask a few questions. Would that be okay?
Yes, please.
Excellent. Why is it that you decided to pursue engineering to begin with?
I felt like it was a career path I can identify with. The people, the jargon, the mannerisms, those kinds of things. I was young, and certainly, but within that first week, I saw what engineering could offer, career, but down the line. But more than anything, I wanted to be a better person, and I felt like engineering had a chance to make me that.
Okay. What have been some of the biggest obstacles that you've overcome in this journey?
Some of the biggest obstacles?
Yeah.
No doubt racism.
Okay.
I mean, let's just get that out there.
That's fair.
Whereas 20, 25 years ago, I may have felt it, may have even seen it, but still too young and not as powerful enough to articulate it.
Okay.
Things are different now. I can say that we don't entirely get the hands-on training. I've seen it firsthand in at least two places of employment. We're the first one's fired, last one's hired, those kinds of employment dynamics. Due to engineering being dominated by white males, it's a good old boys network, you know, in a lot of ways. So those are one obstacle for sure. Another obstacle within that is probably elitism, where, you know, engineering, we know a lot of the everything from 2 + 2 = 4 to what can get us in outer space, astronauts and down the line. STEM offers a diverse range of scientific and mathematical applications. So therefore, there comes I'm smarter than you within that. So you can have racism, elitism, but they can be one and the same, but I can come across a black elite as just the same within that. So just that whole I'm smarter than you, I'm better than you thing. So that becomes a hindrance, not just a burden for people regardless of race, but I think it starts to give engineering a black eye. Those are some of the bad traits that can push people away.
What are some small things that might help reduce some of the inequitable pressures that you've faced?
What are some of the things you can do, you said?
Yeah, not just me, but me representing the profession and educators of the profession.
With you being an educator within a profession, the truth is, I believe you've done all that you can do. You've reached out to me in an engineering capacity, but also culturally specific in an acute way, and I appreciate that. You haven't gone through a broad, paintbrushing and that sort of thing. So you've considered my experience, my cultural relevancy, these kinds of things, all of this into play.
somebody who is 16, 17, 18, 19, 20 is considering engineering as a profession, what advice and thoughts would you have for them?
To any young person considering engineering or whatever it is they're considering, I tell people, regardless of age group, this: you could either be ABCs, you could be a journalist, an artist, a musician, or whatever. You could be 1, 2, 3s. You can be in STEM, engineering, programming, mathematician, whatever. Just pick something that's in your heart. Don't worry about money. Don't worry about social status or this or that. Follow your heart. Don't worry about the dollar bill, period. You'll find happiness that way. You won't have to live with much regret. To any 16, 17-year-old kid looking to get into engineering, I could easily sell you on the joys of it before I'd ever sell you on the perils.
Okay. One last question, maybe before I ask for final thoughts. From a tactical perspective, what steps would you recommend somebody who is in maybe high school or in a career right now that they're looking to transition into a STEM field or engineering specifically? Where are good resources for them to look for those next steps?
Great question. Certainly academically, it could be something as simple as a 1-2 year tech courses, HVAC design, drafting.
So starting with the tech courses, trade schools at a 2-year degree could be a way to scaffold this.
Yes, definitely.
Okay.
2-year schooling. It could also be as simple as, I won't say as simple as, but I've known people who were simply born with wrenches in their mouths. And so, as they said, they were born with wrenches in their mouths. So that is a huge, invaluable experience. Whatever it is, whatever your wrench went to, cars, appliances, electronics, whatever it is you repaired, it is a valuable skill
Solving
set.
those puzzles.
Solving those puzzles. Not everybody has a hands-on experience.
Yeah.
I did. I still don't. At 50, I'm still learning that. So for those that were born with wrenches in their mouths, more power to you.
All right. Thank you so much, Gia John. I really appreciate your time.
Thank you, Rob. Thank you, y'all. Can't believe this.
In this video, I will focus on 3 tricks and tips. 2 of them your instructors probably want you to know. The third one, it's a little sneaky, so I'm going to save that one for the end. The first trick is to make sure you read the exam all the way through, because it is very common for one question to hide the answer to another question. For example, I pulled up a random chemistry test online, and I see the following 2 questions. The first one says, the number of protons in the nucleus of an atom is known as the, and then you fill in the blank. A later question asks, the center or core of an atom is called the, and again, you would fill in the blank. What's important to note here is that the answer to the second question is nucleus. So even if you forget the word nucleus, the fact that it is in the exam gives you at least a hope of being able to answer the question. So if all else fails, read through the exam for fill in the blank things, for multiple choice things, pull answers that appear elsewhere in the exam. It could be you jog your memory, it could be you get lucky, or it could be you get unlucky, but either way you have a better chance than just guessing without any additional information. My second tip comes from Joelle Harris. I attended a workshop that she delivered. She's a professor of engineering at Georgia Institute of Technology, a delightful person. And her advice is to tell a story. When you read a question on an exam that requires an answer, that is a calculation of some value. Let's say you're asked to calculate the current through a resistor. Begin with the destination in mind. State at the very beginning, the very first thing you write there, state, this question is asking about the current through the resistor. The current is measured in amperes. Once you have your destination identified, state where you are now. List the facts that you have. And then identify different paths that you could take to get to your end destination. There could be lots of ways to get to the same answer. List a few of them. Then, pick the one that you feel is best. Might not be the fastest. Sometimes I do things slowly so I get them right. It may be the one you're comfortable with. That's okay. Once you have identified the starting place and the path to the destination, begin the journey. Process the facts through the equations or the algorithm to get to the final destination. Once you're at the final destination, state where you are. You have gone through a transformation. Celebrate that transformation by stating the transformation and comparing that to the transformation you stated you would go through. For example, if you were asked to calculate the current through a resistor, and in the end you said the voltage is 5 volts. That would be concerning because volts, not current. Make sure your units are right. Make sure you actually answered the question. Laying out that story will help the person assessing your work understand where you went wrong, give you partial credit, and give you feedback for improvement. So the third tip that I have, this one is sneaky. Use it with caution. Be very careful. If you come across a question that requires you to do something you don't remember how to do, or use a tool that you don't remember how to use, you might occasionally rewrite the question. You could say something like, I don't quite understand what this question is asking. If it's asking what I think it's asking, it is looking for. Put down the question you'd like to answer. And then answer your own question. So, for example, let's say that I'm asking you to calculate the power consumed by a resistor. It could be that you don't remember the equation for power, but you do know how to calculate the voltage. You might say something like, this question is asking me to calculate the voltage. You'll notice I'm starting another story here, right? By saying that, you're reframing the question. The person assessing it may see that and say, oh, yeah, they didn't understand the question properly, but they know what they're doing, so I'm going to give them most of the credit. Or they might look at it and say, they didn't answer the question. This one could go either way. But oftentimes, at least sometimes, you can get away with it and get most of the credit for a question. So those are the 3 tips and tricks I would like to give you now. I would like to invite you to visit us on the extended campus of Minnesota State University Mankato. I'm part of the Twin Cities Engineering Program, and I'd love to meet you. You're welcome to reach out to me anytime. The best way to reach out to me is my email here. Drop me a line and let's see what we can do together. Additionally, I would love to invite you into the IEEE. This is the Professional Engineering Society for Electrical Engineers.
Good evening. I'm El Nally, Membership Chair for the Twin Cities IEEE, and this is our presentation for Engineer Week on opportunities in the Twin Cities IEEE. There are 3 areas of opportunities, and they include the chapters, activity chairs and teams, and the section officers. The Twin Cities is distinguished by the fact that it has so many chapters. The roles in a chapter include chair, vice chair, treasurer, secretary, program chair, and other roles. The chapters include communications and signal processing, which is a merger of 2 separate chapters from representing the separate societies. Computer, engineering and medicine and biology, electromagnetic compatibility, instrumentation and measurement, magnetics, microwave theory and technology, power electronics and industrial applications, again, a merger of 2 chapters, reliability, aerospace and electronic systems, the consultants network, women in engineering, life members, and study groups, which are ad hoc chapters, and we have 3 of them. The Phoenix Project focuses on a medical device development. Innovation focuses on innovation topics in engineering. And the League of Extraordinary Algorithms focuses on software and especially artificial intelligence. The second area are activity chairs and teams, and they include membership development, which executes the membership growth plan, which focuses on retention in the first half of the year and recruitment in the second half. The senior member elevation team, which helps elevate members to senior member by helping them get their references and providing a single meeting where it can all happen. The membership database and outreach to chapters. The second activity area is communications, which provides outreach to section members and the executive committee. PACE is the professional activity committee for engineers. And lastly, chapters liaison helps existing chapters and starts new chapters. The third area is section officers, and they include the chair, vice chair, treasurer, and secretary. So please join us. And if you're interested, please feel free to contact Ahmed Nauman, our section chair, and me. Thank you.